Welcome to Educon. This is Imam with you, and today we'll learn about the classification and nomenclature of enzymes. Enzymes are divided into 6 classes, each with 4 to 13 subclasses and named accordingly by a 4-digit number. And we have different types of enzymes. Among them, oxidoreductases or dehydrogenases, transferases, hydrolases, and lyases. So coming to oxidoreductases, so here these are the enzymes which catalyze the oxidoreduction between two substrates, that is two different substrates. So we know about oxidation and reduction. What is oxidation? Oxidation is loss of electrons, okay, and reduction is gain of electrons. In the above, in the sequence here, S1 got reduced, means it gains electrons, whereas S2 oxidize, it loses electron. So these enzymes, they catalyze oxidoreduction between two substrates. So S1 will be oxidized and also S2 will be reduced. Coming to transferases, these are the enzymes that catalyzes the transfer of specific functional group, okay, from one molecule to another molecule. So we have here SG is one molecule here, and we have another, okay, group here, okay. So S here, this S, okay, and this S will be forming a bonding with the another functional or molecular group, so liberating another the molecule. So here these enzymes, they transfer a group other than hydrogen, remember that. Coming to hydrolases, hydrolases are the enzymes which catalyze the hydrolysis of ester, ether, peptide, glycosidic, C and C halide and UN bonds, okay. They catalyze the bond cleavage by reaction with the help of water. So here we have a molecule AB, okay, with H2O. In the outcome, what is the formula here? The H will be joining with the B, okay, and A, they will be receiving the OH, so forming a new group here. So these enzymes, especially, they catalyze the hydrolysis of different types of bonds like ester, ether, peptide, glycosidic, and C halide and UN bonds. Coming to lyases, these are the enzymes that catalyzes the removal of groups from one substrate by mechanism other than hydrolysis, leaving double bond. So here there is no any water is involved in lyases. What happened? We have the formula here, okay. Here you see how the enzyme is acting. So it removes the groups, it removes certain groups without involvement of water, without any hydrolysis, making double bond between the carbon and carbon. What are cofactors? Enzymes are composed of one or several polypeptide chains, that we know already, okay. Enzymes are, almost all enzymes are proteins, but in many cases some non-protein constituents called cofactors are bound to the enzyme, which makes the enzyme catalytically active. So enzymes are composed of one or several polypeptide chains, but in many cases the chain may be non-protein constituents called cofactor, so are bound to the enzyme to make enzyme catalytically more active. In such cases, the protein factor, for example, I said, in general, what are enzymes? They are the linear chain of amino acids. So this is the protein structure. So sometimes we have another structure which is non-protein. So here this is the non-protein and this is a protein. In such cases, okay, this protein factor is called apoenzyme, okay. Remember, now you understand. So we have all enzymes are made up of one or several polypeptide chains. Among that, certain chain will be non-protein constituents, which is involved with the enzyme itself. So at that time, this protein part is called as a apoenzyme. Okay. Okay. Three kinds of cofactors may be identified. Okay. Three kinds of cofactors, that is, one is prosthetic group, coenzymes, and metal ions. These are the prosthetic groups, coenzymes, and metal ions. Prosthetic groups are organic compounds and are distinguished from other cofactors in that they are tightly bound to the apoenzyme. What is apoenzyme? It is a protein part of the enzyme. Okay, this is the prosthetic group, and it is distinct from what is it? What does it make? What is the important in this prosthetic? What are the specific thing to be considered in prosthetic group? That they are tightly bound. They are tightly bound to the enzyme, and that is apoenzyme. Like examples, you can take peroxidase and catalase, which catalyzes the breakdown of hydrogen peroxide to water and oxygen. Heme is the prosthetic groups and it is part of active site of the enzyme. Now you understand here, we have an enzyme, we have a prosthetic group, okay, and we have a substrate. Coenzymes. Coenzymes are also organic compounds, but their association with the apoenzyme is only temporary or transient. Okay, usually occurring during the course of catalysis. So during catalytic reaction, this coenzyme, they will join with the active enzyme. Okay, coenzymes serve as cofactors in number of different enzyme catalyzed reaction. The essential chemical component of many coenzymes are vitamins. Okay, the essential chemical components of many coenzymes are vitamins. Remember, the coenzymes are also organic compounds, but their association with apoenzyme is only temporary. Okay, and mainly they are vitamins. Okay, example, you can take coenzyme nicotinamide adenine dinucleotide and NADP containing the vitamin niacin. Okay, this is also important. You must remember this line. Okay, we know the difference between the prosthetic group, coenzymes. Okay, coming to the cofactors. A number of enzymes require metal ions for their activity, which forms coordination bonds with side chains at active site, and at the same time form one or more coordination bond with the substrate. For example, this is the protein structure. Okay, fine. So as we know that the chain folds itself into many folds. Okay, this is what the how the protein and enzymes, the structure of protein and enzymes will be. So number of enzyme here, what is the definition here? What are the cofactors we are discussing? A number of enzymes require metal ion for their activity, which form coordination bonds with the side chain. So here we have two chains, okay, made up of amino acids. Okay, we have active sites, so these, and also form one, we have a substrate. So what happened? This metal ion, they form bonding with the active site and also with the substrate. Okay, like there are so many cofa, like Mn, like we have Fe, and different metal ions which acts like a cofactor for many enzymatic reaction. Example, you can take zinc in cofactor of proteolytic enzyme carboxypeptidase. Okay, so a number of enzymes require metal ion for their activity, which forms coordination bonds with the side chain at the active site. Okay, at the active site. So we have this is also active sites. Okay, you can see, we can, for example, if we take this active site, okay, it will form the bonding here, and also with the same time it will form another bonding with the side chain. Okay, and the substrate. Okay, an example, you can take zinc is the cofactor for the proteolytic enzyme carboxypeptidase. So we'll discuss a small, brief summary about what we learned. There are 20 types of amino acids and 5 types of nucleotides. Only 3 types of macromolecules, that is protein, nucleic acid, polysaccharides, are found in living system. Macromolecules are polymers which are made up of building blocks and which are different. Proteins are heteropolymers made of amino acids. Proteins serve a variety of cellular functions. Okay, many of them are enzymes. Many of the enzymes are also proteins. Some are antibodies, some are receptors, some are hormones, and some other structural proteins. Okay, and coming to this, collagen is the most abundant protein in animal world. Remember this, we discussed in the earlier slide. This is the important point to remember. Collagen is the most abundant protein in animal world, and ribulose bisphosphate carboxylase oxygenase, ribisco in a short term, is the most abundant protein in the whole of biosphere, including plants, everything. So whereas the collagen, it is present only in animal world. Ribozymes are nucleic acids with catalytic power. Yes, okay. Enzymes lower activation energy of the reaction. Enzymes lower activation energy of the reaction and enhance greatly the rate of reaction, because without enzyme the reaction, we learn that without enzyme the speed of the reaction, any chemical reaction is very less, and in the presence of enzyme we saw multifold, million times increase in the rate of the reaction. Polysaccharides are components of cell wall in plants, fungi, and also exoskeleton of arthropods. They are storage form of energy, that is starch and breath. So with this we conclude this chapter, biomolecules. In next video we'll discuss different types of questions, how to learn, how to prepare for the questions and how to answer the questions from the NCERT. Okay, thank you, and please subscribe to my channel, and it will encourage us to put a lot of educational videos in our channel. Thank you once again.